What are the long-term impacts of climate change on ocean currents? Imagine the vast ocean as a giant conveyor belt, moving water around the globe. Climate change is changing how this belt flows, and that can have big effects on marine life and the environment. Ocean currents are like giant rivers within the ocean, driven by differences in water temperature, salinity, and wind. These currents help regulate Earth's climate by moving warm water from the equator toward the poles and cold water back toward the tropics. When climate change causes global temperatures to rise, especially at the poles, it affects these currents in several ways. One major change is that some key deep ocean currents, driven by differences in water density, are slowing down. Warming waters at the poles make seawater less dense, and melting ice adds fresh water, which further disrupts the sinking of cold, salty water. This process, called thermohaline circulation, is like the engine that keeps the global conveyor belt moving. When it slows, less oxygen and nutrients reach deep-sea habitats, creating low oxygen zones where many marine species struggle to survive. It also means the ocean becomes less effective at absorbing carbon dioxide from the atmosphere, leading to higher levels of this gas in surface waters and increased ocean acidification. Acidification makes it harder for shell-building creatures like corals, mollusks, and some plankton to grow, which affects the entire food web. Meanwhile, surface currents can speed up in some areas because warming causes the water to stratify, or layer, more strongly. This creates a thin, fast-moving upper layer of water that is warmer and shallower. These changes can shift where marine animals live, breed, and feed, forcing them to move or face population declines. The overall impact of these shifts includes disrupted nutrient cycling, which limits food for plankton and larger animals like fish, marine mammals, and seabirds. Increased ocean stratification reduces vertical mixing, leading to more dead zones with little oxygen. Ocean acidification harms creatures that relying on calcium to build shells and skeletons, threatening coral reefs and biodiversity. Changes in temperature distribution affect the timing and locations of breeding and feeding, causing shifts in ecosystems. More frequent marine heat waves can bleach corals and destroy habitats, which then ripple through the food chain. For marine life, these long-term changes mean habitats are shifting, waters are becoming more stressful, and food sources are less reliable. Species that cannot adapt quickly may decline or disappear locally, impacting entire ecosystems. So in the end, climate change is not only slowing down some of the ocean's vital currents but also speeding up others, leading to less oxygen, more acidity, and changing temperatures. These shifts threaten marine animals and ecosystems, making it harder for them to survive and thrive in the future.